This is Dr. Antoine. I'm going to show you how you can apply another method named technique for order preference by similarity to ideal solution, TOPSIS method. And this method is among other methods of multi-criteria decision making that have been presented, and there are many methods which have been developed to assist managers and decision makers so as to improve the way they make the decision. And this is another method. Remember, in our previous videos we have presented the weighted sum model. We also have presented the weighted product model, evaluation based on distance from average solution, meet objective optimization on the basis of simple relational analysis. And this is another method that can help you to improve the way you make a decision. And the principle of this method is that the chosen alternative should have the shortest distance from the best ideal solution. And there are many steps that you have to perform. You have to calculate the normalized matrix, and then you calculate the weighted normalized matrix, and you calculate the ideal best. You choose the ideal best and the ideal worst values, and then you calculate the difference of each response from ideal positive or positive solution, and you calculate also the difference of each response or each value of normalized matrix from ideal negative solution, and then you calculate the corresponding closeness for coefficient or the alternative of or preference score of your alternatives. As you see here, we are working on the same decision matrix so as to find out whether there is any difference in our results using any of our methods that have been presented in prior videos. And as you can see here, the problem here is to select a car based on these criteria: quality, condition, security, days delivery days, fuel consumption, and the price. And now, as you can see, we have many cars that we have to do, but you have to select one, and we need a model which can help us, which can assist us to find which car we can buy. Because when you look here, you see these values. As you can see, they cannot be added, or you cannot make a summation of these values because they do not have same usual. That's why we need to make normalization. We have to normalize this. We have to normalize our decision matrix so as to have the same usual of our variable or decision matrix, which has different measure. Now, friends, let's go and I will show you how you can use this method. The first thing we have to do is to raise this value square root. We have to find square root of all these values, our decision matrix. I take this value and the square root of this value, and I press enter. Then I can copy this formula as we are using Excel. I can copy this. This is the square of our matrix, as you can see here. And then now the next thing to do is to find the summation of these, our values, sum for each criteria, summation. I press enter. I can copy this formula until the last criteria, and then the next I have to find the square root of this value so as to use it to make a normalization. Now I have in Excel the function is racine. You have to find the function corresponding in when you are using English computer. Now I have to make square root of this value. I press enter. Now I can copy this formula. Here I can, or other criteria, I can copy this formula to other criteria. Now the next step is to normalize our matrix, because our matrix do not have same measure. You see we have a measure for using first, and this is count days this is in euro or dollar. It can be in euro, it can be in euro, dollar, or other francs. And now I have to make a normalization. What I will consider each value of our decision matrix, and I will divide by this root. All these roots we have calculated for each criteria. Now I found this value, this one, divided by the root I have calculated on quality. Here, this root, this one, this. And I have to add the symbol dollar so as to copy the formula. Now, as I take the value of the decision matrix and I divide it by the square root of this value, this criteria. So now I can copy this formula all in all. And now this is our decision matrix. Now remember, I have said that the weight for each criteria have been given in with our decision matrix, but remember you can calculate yourself the weights if they were not given using whether you can use objective method or subjective method or integrated method. And now I can, the next step is to calculate the weighted normalized matrix. Now, what does this mean? That means we have to multiply each value of our normalized matrix by the weight of our criteria. Now, let's show you, friends, how you can do. It's very easy when you work in Excel, and when I take this value, multiplied by this value. To copy this formula, I have to add symbol dollar between this letter and the number. Here, I press enter because this will not change. It can go like here, but it cannot move down. Or it cannot go down. That's why I have to fix it. I do like this, and with that, I can copy this formula in all rows like this. For all criteria like this. Yeah, I finished. This is weighted normalized matrix. You can see now here, as you can see here, this is this one multiplied by this one. This one, you see now, this one. And this value is, as you can see here, it is this one. You see here. Now, as you can see, this is correct. Now, what is the next step? The next step is to choose ideal values and negative values. Now, to choose these values, it depends on your criteria classification or the nature of your criteria. Because remember, we have beneficial criteria and non-beneficial criteria. Remember, I have explained what means beneficial criteria and what means non-beneficial criteria. Beneficial criteria are those criteria for which we need the highest value. For instance, for the quality, we need a car with the highest quality. Non-beneficial criteria are those criteria for which we need the minimum value. For instance, for the price is a non-beneficial criteria because we need a car but at the lowest price. Now, an ideal value for beneficial criteria would be the highest value among each beneficial criteria, but it will be the minimum value for non-beneficial criteria. But in negative value here, for beneficial criteria, it will be the minimum value. And here, it will be the maximum value, negative value. Now here, I use the function max. In Excel, max. I choose the maximum value in our criteria quality. And I can copy this formula until these last criteria of beneficial criteria. But for non-beneficial criteria, the ideal value is the minimum value. Now I can write here minimum. Now I choose the minimum value in delivery dates. I press enter and I can copy this formula for non-beneficial criteria. Pay attention, look how your decision matrix is built, and do not confuse because you can make error when you don't pay so much attention, so as to make a classification of your criteria in the beneficial and the non-beneficial criteria. And as you can see, in many methods, the way you make it, for instance, normalization depends on whether the criteria is beneficial or non-beneficial. That's why you have to understand what you are doing. Now, here, negative value is in beneficial criteria is the one which has the minimum value. Now I have to find the minimum value because we are in beneficial. We need the highest value, but the worst solution is the one which has the minimum value. This one I choose the minimum value, and I can copy this formula here until only on beneficial criteria only. Now the next step is also to find the maximum value for non-beneficial. I find the maximum value here. I press enter. Then I can copy only on non-beneficial criteria. These are choosing ideal-based solution and negative solution in weighted normalized matrix. Now, what are the next step? The next step is to calculate the ideal best and the ideal worst values. And here I'm going to show you step by step how you can do it. Friends, you have to pay so much attention here, because when you make a mistake, it will affect your final decision. That's why you have to be aware that you have to pay so much attention on this step. And when you need formula, take on the internet, TOPSIS method, you will find a formula. Just me, I'm practical. I don't want to show you so much theories, but you need to understand what you are doing. Now, how will we find ideal best and ideal worst? We consider each value here, this value minus this value for ideal best. But when we are working on a negative value, we consider this value minus this one. We will put on square, and we will add, or we will make a summation of this value. At the end, we will raise at 0.5 our final values. Now let's show you slowly how you can do, but you have to pay so much attention. I press equal to indicate that it is a function. For ideal best, I do like this. I take this value, this one, minus, look friends, I go slowly so as to see what we are doing. I go calculating the ideal best solution. Now, minus this value. We will work only on this law, because we are working on ideal solution. When we will be working on ideal negative values, we will work on this law, use these values. Minus this one, but I have to fix this one like this. I have to raise this square plus parentheses this value minus this value. I have to fix it. Look, square 2. Then add this value, sorry, parentheses, I forget, this value minus this one, add your values, but I have to fix this value like this, square to the power of 2, plus parentheses, this value minus this one. I have to fix it like this, to the power of 2, plus parentheses. You see this value minus this one, but I have to fix it also so as to copy down the formula like this, to the power of 2, plus this value, sorry, parentheses here, minus this value, but I have to fix it like this, and then to the power of 2 like this. Now I have to close the parentheses, but I have to raise to the power of 0.5, and then I press enter. Now you will see, as you can see here, I have considered this one and these values. Now I press enter. Now I finish, friends. This is for ideal best for the first car. I can drag down the formula like this, and I will do the same, but what will change is the value that I can use when I will be making minus, because I will use this value, this one. Okay, friends, now I'm going to show you how I can calculate the ideal words. It is the same formula, but I will use these negative values. Okay, friends, we go. I press enter, I open parentheses. I take this value minus this one, but I have to fix this value like this, to the power of 2, like this, plus I open the parentheses, this value minus this one, which I have to fix like this, to the power of 2, raised to the power of 2, like this, plus this parenthesis, this value minus this one, worse value, negative value, but I have to fix it like this, to the power of, raised to the power of 2, plus parenthesis, this value minus this one, but I have to fix it so as to drag the formula down, to the power of 2, plus this parenthesis, this value minus this one, negative value. I have to fix it like this, and then I raise to the power of 2, raise to the power of 2, plus this value, sorry, parenthesis here, this value minus this value, but I have to fix it like this, and to the power of 2. I cross the parentheses, this one which is opened here, and I put raised to the power of 0.5 like this, and I press enter. Now, as you can see, friends, you have to pay so much attention. Don't make a mistake. In place of using this value, don't use this value, because that's why I'm explaining you slowly by slowly, and you see how you will work using TOPSIS method. Now I press enter. I finished. Now I have to drag the formula down like this, or to copy the formula like this. I finished to calculate ideal words value. Now what I'm going to calculate is the preference score, or the index of closeness. Now I do like this. This is the formula: ideal words divided by the summation of ideal best and ideal worst. It is equal ideal worst value divided by the summation of this value plus this one. I press enter, I press enter, and I drag down the formula like this. Now what is next? Now this is our preference score. Now I can now ranking. I use this function rank because I'm working in French. This one, this value, I have to show the matrix which will be fixed so as to allow to drag the form, to copy the formula. Now I fix this matrix like this, like this, and I close the parentheses. Now I can just drag this formula here. And friends, as you can, index of closeness coefficient, you just can put this value in a percentage. As you can see here, it is 57, and the highest value, as you can see, it is this one. Now I can just highlight this value by using this for this way, but I need one value here. Now you see the value which had the highest closeness value, Euclidean value, distance value is this one, and this was ranked the first, and the preference score is the highest here. Now, as you can see, friends, this method TOPSIS has the same conclusion as the previous method. Technique for order preference by similarity to ideal solution proposes us to choose the card 5, number 5. As the previous method, weight is our model, weight the product model, evaluation based on the distance from average solution, objective optimization on the basis of simple relation analysis. All these four methods have proposed Docker or have chosen Docker 5. It is the same conclusion when we use technique for order preference by similarity to ideal solution. Now, as you see, friends, this 5 method concludes that car 5 can be chosen as the best solution, the best alternative, the best car. Now, as you see, friends, I end this presentation. When you found this video helpful, you can share it, you like it, you can share with your friends so as to let them learn a new method which can help them to make better decisions. And you can subscribe to my channel so as to continue to have other videos which can help you to increase your knowledge. And thank you for your attention. Bye for the next video.